In this video, I'm going to show you how to balance a bit more of a complicated reaction. So for this video, I am showing you reaction number 9 on the Balancing Chemical Reactions worksheet. So here's our reaction. Notice it's a combustion reaction. Oxygen is a reactant, and carbon dioxide and water are produced. So we're going to start this balancing process off the same way we always do, where you write your reactants, your products, and we have carbon, hydrogen, and oxygen. Okay, so we start off with 7 carbons, 6 hydrogens, 2 oxygens, and then there's another 2 oxygens. So really, on our reactant side, we have 4 total oxygens. And then on our product side, we have 1 carbon, we have 2 oxygens, 2 hydrogens, and then another oxygen. So that's really 2 plus 1. So we really have 3 oxygens on our product side. Okay, so there's a lot going on here. Nothing is balanced. Where do we start? Well, I want you to notice that on our reactant side, oxygen always has a 2, which means oxygen is always multiplied by 2. So oxygen cannot be odd. Okay, so let me repeat that. Any coefficient that we put in these spots, because oxygen is multiplied by 2, we will always have an even number of oxygens. Because oxygen is always multiplied by 2 because it has a 2 as a subscript. So that means on our product side, the oxygen also needs to be even. So this oxygen is always going to be even because it's multiplied by 2. But this oxygen, if we had an odd coefficient, like a 3, then we would have an odd number of oxygens. So that means our coefficient here needs to be an even number because we can only have an even number of oxygens. So with that in mind, we're going to start balancing. And I want to think about this, and we need to have an even number in that spot. So right now, if we have 6 hydrogens on our reactant side and 2 on our product side, we would put a 3 here. But if we put a 3 here, oxygen is now odd. So we know it can't be a 3 there. So what do we need to do? Well, we need to multiply this whole thing by 2 before we even start, because we need to change hydrogens, the number of hydrogens, so that way we put an even number here. So when we multiply that by 2, and I'm just going to change the number, so when we multiply this by 2, this becomes 14 because 2 times the carbon gives us 14. Then our hydrogen becomes 12 because 2 times the hydrogen, 2 times that 6, gives us 12. And our oxygen, 2 times our oxygen, that would be 4. But then we need to add another 2. So really we have 4 plus 2, which is 6. We have 6 oxygens. Okay, so now we're going to start by balancing. First off, I want you to notice that oxygen shows up in every single compound. So we're going to save balancing oxygen last because anytime we balance anything, oxygen is also going to change. Anytime you change any coefficient, that's going to affect oxygen. So let's start with our carbon. We have 14 carbons on our reactant side, so we would need to put a 14 here because this carbon has no subscript, so 14 times that 1 gives us 14. And now 14 times our O2, our 2 oxygens, that now gives us 28, but plus our 1 oxygen from H2O, so that's 29 total oxygens on our product side. So now let's balance our hydrogens. So our hydrogen here, we have a total of 12, and here it's 2, so something times 2 needs to equal 12, so that's going to be 6 times 2 will give us 12 hydrogens. So now our hydrogens are balanced, but this 6 also affects that oxygen. So we have 6 oxygens here, plus the 28 oxygens here. So 6 plus 28 gives us 34. Okay, so we have 34 oxygens. So I want you to notice, our carbons are balanced. That's good to go. Hydrogens, balanced. Good to go. Oxygens are not balanced. If we mess with this, so we need more oxygens on our reactant side. If we mess with this coefficient, we would change the number of carbons and hydrogens. But carbon and hydrogen are already balanced, so we don't want to do that. So we're going to put something here for this coefficient, for that oxygen. So we need to get to a total of 34. Right here, we already have 2 times the O2, so that's 4 oxygens. So we already have 4 oxygens from this compound, so we need 30 more. So something times 2 has to equal 30, so that's 15 times 2 will equal 30. So now from here, we have 4, and from here, we have 30, so we have a total of 34. So now we are all balanced. And our final equation should look like this.